Morning from us, afternoon, I think, from your end. I'll just wait a few more minutes, just another minute or two, and just wait to see who else joins us. Pedro, welcome.
Sure.
Just waiting a few more minutes, Pedro. Just started. Yeah, mic is muted, Ken. Just for the purposes of now, it's muted. But at the end for Q&A, we'll open it up and we can have a bit of a round discussion for the last sort of 10 minutes or so.
Please, while you're waiting, please feel free to, maybe we'll start in about a minute, hey?
Yeah, I think we'll start.
Probably enough time for everyone, yeah. Yeah, feel free to use the chat or the React buttons. Would love to hear what you guys think, and yeah, would love to hear from you in general through the presentation. So yeah, thanks everyone for being here. So I'm Nishara. You would have seen my face. Oh, this is weird. I've just noticed a weird thing about my cursor. Anyway, yeah, you would have seen my face in the in the ad. My background is in process engineering and in coal processing, and after that, I sort of did some analytics and visualization, and now I get to be product manager at Clarofy. And I've got with me Johnny, so you can introduce yourself, Johnny.
Sure. Thanks, Nishara. Yeah, Johnny, or Jonathan Gammas. I'm the Chief Technology Officer at Clarofy. I'm a software engineer by background, but I've worked in minerals mining, metals for pretty much my whole life. And I'm at the moment we're sort of heading up the product development space, particularly with Clarofy. We're pretty passionate about our product that we're going to show you a little bit later today. But to give you a bit of an agenda, Nishara is going to take you through today a bit of an example in a copper gold plant, and just talk to you about the issues and the problems with dealing with noisy processing data, and then she'll give you a bit of insight into sort of how we've done that in the past before with sort of traditional tools, and then we'll segue into how you could do that a lot faster and better and clarify. And then we'll have a bit of a Q&A. So more than anything, we hope you guys get a lot of information out of it, if anything. And then, yeah, love to catch up with you and get some thoughts around what you would like to see in terms of additional webinars or content that is interesting to you guys, or sort of impacting the way you work today, particularly with analytics. So again, so thank you for coming. We hope you enjoy the session today, and now I'll just hand it over back to Nishara.
Thanks. Yeah, so let's jump in. So Johnny kind of already went through the agenda, but I'll just mention that we've had a couple of webinars before that have used the same example. So if you've been for some of our other webinars, you might find this familiar. So the example is some work that we did for a copper gold sulfide flotation circuit in the reagent addition area. So we did one quite recently about building the hypothesis for this example. So this kind of what the work that we're doing today kind of leads off that. So once you have your hypothesis, how are you going to go ahead with your analysis? So that's sort of the question we're answering today. And we do also have a separate webinar that you might have been involved in about stabilization, stabilizing your plant and making your plant a bit more consistent. Again, using Clarofy, our data analytics app. So yeah, so thanks everyone for joining us. We will jump right in with some common struggles that we see, or common challenges that we see. I'll say it again for those who joined recently. So your cameras and your mics are by default off. However, at the end, we'll we'll make it possible for you to turn yourselves on, and you can ask questions if you want. But please utilize the chat. Would love to hear from you all. Whereabouts you're from, maybe what resource you work in. If you're working in a processing plant or some other process, I would love to hear the background there. And also any challenges you face in analytics, because we'd love to kind of cater our webinars to what can be helpful for our audience. So great. All right, I'm going to jump right in. Okay, so the situation that we come across a lot of the time is that reality is messy. Any one of you who have dealt with real data, if you like, so data that's from sensors that are out in the field, you know that data that you get back is quite noisy, it's quite messy, and it kind of feels like it's difficult to make a clear judgment or a clear decision based on this kind of this mess of data points. It feels like insights are hidden and the value is locked in the data, and perhaps we don't have the tools, or perhaps we don't have the ways of thinking to figure out what is this data telling me, and what are the different areas I can look at in this data. And then a secondary issue is we all want to use our data to make decisions, and we want to use our data to influence decisions, right? And you want to make a recommendation and see it happen in your plant, or you want to keep improving your plant. And usually we want to back our decisions up with data. And what we tend to hear from process engineers and metallurgists is, it's difficult to make a recommendation because I'm not believed. Like I'm not, I don't have the data to back me up, or the data is not clear enough, right? And which is completely understandable if you have some noisy data and you're saying, see, it's right here. That doesn't always come across if you just have a messy plot. So what we're going to do today is talk about a real example where we came across this very issue. So as I said before, it's a copper gold plant. Move myself away. The question, or the issue at hand was that the Met team were trying to reduce costs and were focusing on reagent costs. So can we reduce our reagent dosage while keeping our recovery up, and therefore get a cost benefit? Again, if you attended our hypothesis webinar, we go a lot into, what is this question like? What is that ultimate question that's going to direct our analysis? That's a great one. Would recommend if you haven't already attended that. We'll probably be doing it pretty soon, so just keep your eye out. Yeah. So the questions that my team were asking is, how can we understand more about this relationship between float recovery and reagent addition? When we increase reagent, is there actually an increased recovery, or was there some other factor, like just at the time that we increased reagent, perhaps there was a quality increase, feed quality increase, or something like that, some kind of confounding or compounding or overwhelming variable. How do I know that overwhelming variable was in operation or not? And ultimately, can I improve my recovery just by adjusting my reagent? So this is the graph down the bottom that we are most interested in. So the variable is reagent dosage, and our float recovery is what we're trying to change. So we would call that our KPI, or our dependent variable. So as you can see, it's it's a little bit blobby. To my eye, it kind of looks like it has a positively leaning relationship, but as many of you might have realized, we are kind of subliminally affected by outliers. So it's my cursor around here. So over here, there's fewer outliers, and there's kind of more up here. So is my brain kind of pushing the pushing the line that I would draw through this in a positive direction. I don't know. It's just a blob of dots really at this stage. So what I'm going to talk about is a couple of steps that we can use when we have noisy data to find some insights quickly. And I guess it's accurate, but it's a first step accuracy, right? So this is not everything in data science. This is not a like the sum total of all the knowledge about analytics. This is just some tips that personally I think is really high bang for buck. So they're quite simple tools. You can do them on Excel. I'm going to show you how to do them on Excel. There's a lot of easier ways to do it as well. I'm going to show you a better way. But they're very powerful for the short amount of time that you spend on them. They're very powerful in terms of seeing trends and getting insights out of data. Yeah.
Sorry to interrupt, Nishara. You really can't see any of the content. Is everyone else having the same problem? Are they experiencing the same? Can you see the screen? Just give us a thumbs up. There might be a quick way to do it.
Just move the screen. Can you see that? It should say byte. It's kind of 4 hexagons behind me.
Okay, yeah.
It might be.
It's okay, yeah, okay.
Everyone's okay? Because when we did the dry run, we did have some issues with the Linux operating system. So I think most operating systems, it should, as in Teams on Windows and others should be fine.
Mm.
But
yeah, really, it might be just good to restart your just log back in and the conference session. I think everyone else can see it. Yeah.
Okay, awesome. All right. Well, I will continue in that case. So yeah, please, would love to hear from you if you come across issues like this with analytics, if you've struggled with noisy data or anything like that. Please, yeah, put it in the chat or hold on to your questions until the end. But our methodology that we're going to talk about today, we call it BITE. What these stand for is B for binned scatter plot, I for integration, T for test, and E for evaluate. So I'll go through each of them in short. So binned scatter plot, it's a simple visualization technique. It's taking that scatter plot that we just saw and kind of putting the x-axis into groups, similar to what you would do for a histogram. Just so that, but it's still a scatter. So you can see all your points in each group, and you can make out your trends a bit easier. So you'll see some examples. If you haven't ever encountered this, you'll see some examples coming up. But that's usually the first step that we do here, and we find it super useful. If you don't know your data well, you want to do just pick your 30 most relevant variables and just do bin scatters for all of them. That's kind of like first step for us usually. Integration is a word we use here at Clarofy. It's not, what we mean by it is not the opposite of differentiation. We mean something a little bit similar to normalization. So it's kind of like the removal of an overwhelming variable. It's kind of applying a regression function to your main KPI to account for your overwhelming variable or variables. So you're trying to remove the relationship of some variable against a KPI. We'll go into it. T is for test. There could be so many ways you could test your recommendation. So after a few cycles of looking at some bin scatter plots, integrating, looking at the bin scatter plots again, you might come to a recommendation or a hunch, or you have some metallurgical understanding of the data that you're seeing, and you have this idea that, okay, I think this is the way we should go, or I think this area is better than this area or something, and you want to test that statistically. So that's what we're talking about in this test area. In this example, we're going to use a t-test, but there's plenty of other statistical tests you can do. but we're going to go through a t-test, very, very commonly used, very easy. Evaluate, so this is usually something we do right at the end, maybe even after, maybe at this point, sometimes we have a like a trial implementation or something that we then have to do more tests after, statistical tests. And the evaluation is kind of figuring out what is the actual, like what's it worth, right? So, and this might be in your, recovery. In this case, recovery is our KPI. So how much recovery can I actually get out of this improvement? Or it might be something like tons. So, you know, how much extra throughput can I do if that's your main KPI? And if you have the data, if you have all your kind of revenue data, you could even evaluate the monetary impact of the change that you made. So one thing you'll realize is, I mean, this is linear in terms of it goes across the screen, but there's arrows going back and forth. And the reason for that is this is an iterative process. And we've always found that you kind of go back and forth a few times. You want to check your results. Going through it once is super simple and quick. And so that's, you know, I guess something you can do with a very short amount of time. And the more time you have, you can do more of those cycles, I guess. So it's kind of quite a great process for people who are already busy and they just want to check something really quickly. So so we find Byte like really, really useful. It's simple. So it's one of the kind of basic methodologies that we would use. When there's more complex things to come, we usually add it on at something. Maybe you're making a model, maybe you're, you know, putting some other design stuff into it. Maybe you're creating an algorithm, maybe you're making some predictions. All that stuff would come in kind of on top of this, but these are kind of first steps. So hopefully it's helpful, and let's go straight into bin scatter plot. So I'll let myself away. So this was our initial scatter plot, the reagent against float recovery, and this is what the same relationship looks like when it's binned. The lines in the middle are medians for that group, and the boxes are the confidence interval of the median. So when you do your bin scatter plots, you can have medians or not have medians. We find medians really useful. The boxes can be quartiles if you want. They could be box plots if you want, or something else that's useful to you. We find the confidence interval of the median is super handy. So that's how it works in Clarofy. So in terms of bins, in order to know what size bins to do, it's a little bit dependent again on your data and on your process. You know, you could bin it into categories representing, you know, how much reagent addition you can put. So in your process control system, maybe your reagent pump only goes up by 5% at a time. That wouldn't be the case here because it's grams per ton. But you know, if it was, if you're, you know, if the notches that you turn up are only 5% at a time, you know, you wouldn't want your bins to be at 1. Bins of 1 or bins of 2, because there's no way, like between the bins, there's no way you could make a practical change. So you got to think of things like that with your number of bins. You'll notice that compared to this one, this trend is a lot easier to see. It's mostly flat at the start, and then there's a little rise and maybe a peak somewhere here, and then it comes down again. And that's a lot harder to see in this, but very easy to see here. And you can imagine that if we even went down in bin size, if we had a bin size of 0.1 or something, that relationship would be even clearer. So, but might not be useful practically. So, so that's all that bins are. Let's look at how to make them on Excel. All right. So some of you may have already done this, so you know, feel free to add your experience on the chat if you like. I think this is probably the best place for me to be. Okay, so here's the general rules about how to do a bin scatter on Excel. You end up with something like this. So you have your data, you'll receive your data, and it will most likely look something like this. You'll have your variable of interest that you're going to bin, and all you have to do is create a new column and call it whatever your variable is and bin, or label your columns basically, so that you know what they are. And what you want in this column is a lovely looking if statement, and the more bins you have, so the smaller the bin size, the more ifs you're going to have. And I'll just point out that Excel does have an upper limit for number of nested ifs, so be aware. So yeah, basically you're saying if this value is between this value and this value, round it down to this value or round it up to this value. You're just doing that over and over again for the range of that variable. So then you get your binned variable, and then you need a whole new table where you collect your bins and you make all these little statistical features of each bin. So the median is just median formula on Excel. So you just spell it out median, and then you have to do an if statement for where the reagent bin is to. So when this is equal to the rows over here. So you kind of have to connect it back to this table. Yeah, so Excel already has a median formula, so you just use that. Standard deviation, you can use stdev or stdev.p for population if you like. I think this one was used with the population standard deviation. Sample size is just a countif, and confidence interval, you want confidence.norm. And I have used 0.05 as my confidence interval. So as 95% confidence is what I'm after. Obviously, you're welcome to do whatever confidence you want. And then what you want to plot is your this variable, your binned variable. You want your median on top of that, and you want your confidence interval on top of that as a line. So you might or might not be able to see it over here. So it's the gray kind of lines in the middle. So as you can see, this is it's a process. It's not extremely quick, but it is very powerful, and allows you to have this bin scatter at the end of it. Again, this is an iterative process. You might need to try different bin sizes, and perhaps different X and Y variables to do your exploration. So this is all in this exploration stage where you're going like, I'm not sure, maybe this works, maybe this works. So that's a bin scatter in Excel. Once you have your bin scatters, potentially, you might be noticing kind of what's going on metallurgically. You might be thinking, are there other factors that are impacting my recovery? For this particular case, we knew from the Met team on the site that the feed grade for this plant actually had a really strong relationship with recovery. So we knew that that was something we had to account for. So our next step after looking at some bin scatters was definitely integration. So integration, as I talked about before, is simply removing the effect of a certain variable, usually an overwhelming variable. So this is the feed grade for this plant, and this is that fluid recovery. Quite typical. If the feed grade is increased, usually you get higher recovery as well. You normally or typically get a really strong positive relationship here. What we're trying to do is flatten this relationship so that it's as if your new modeled recovery is as if feed grade doesn't have any impact on recovery. So I hope that's clear. It's normally a bit of a tricky point to understand if you've never used it before, but try and think of it as the same sort of methodology as normalization, where you take something that's not a normal distribution and move it into a normal distribution. Similar thing. So you're kind of doing a really simple regression model in this case. So So that's what integration is, and let's find out how to do it on Excel. Also, just a point, there might be more than one variable affecting your KPI, by the way, and you can easily imagine that in a plant setting. So you could have like your feed quality, you might have multiple feed qualities. You might have something like your throughput rate. So perhaps a higher throughput rate would give you less recovery because there's more material going through. So you'd have a slightly negative relationship there. You might have some other, like grind size or a sizing ratio or something like that that has a really strong relationship with recovery. So, you might have multiple. Let's move to how to do this on Excel. All right. So again, it's a few steps, but just bear with me. I'll talk you through it. So basically, you want a scatter plot of your, which you might already have at this stage because you just made a bin scatter plot. So you want a plain scatter plot of your feed grade or the variable that you think is overwhelming against your KPI, and you want a regression line. So you can get this line from the regression function in Excel, or I think there's a way to get it out of the plot straight away. So I think you can do a trend line and then extract the formula of the line. So that's all you need, and what you need is two new columns. So you got your normal recovery column, which is these blue dots. You make a predicted recovery column. Let me move myself to the other side so you can see. So you got your predicted recovery column, and what you're doing here is just putting this line formula into here. So you're having the straight line numbers. And then you're going to make your second new column is your integrated recovery, and this is just your actual KPI. So this one, the float recovery, your actual KPI minus your predicted KPI plus the mean of your predictions for each row. So that's all your integrated recovery is. And when you plot that on top of the other one, you'll get something like this. So you can see the blue line is quite positive. And you can see the orange line, which was the trend line for the orange dots, is horizontal. It's flat. So to sort of show you in detail, you can kind of see, step away again, you can kind of see these three dots over here. It's just easy. I'm just picking a pattern that's easy to see, but you can see that it's at relatively low feed grade, or definitely lower than a mean or a median, right? So low feed grade, and it's got low recovery, right? So if we go over here to where we have integrated this variable out, you can see that in the integrated version, these three dots have increased in recovery. So what we're saying is, if it wasn't for the effective feed grade, those three data points would have higher recovery. They're only at a lower recovery because they had a lower feed grade. Do you know what I mean? So most of these points will have moved up because they're only down because of the effective feed grade. And same with most of these dots up here will have moved down in order to make that relationship flat. So hope that's clear. Hope that's understandable. Please, as before, let me know in the chat if you've seen this before, if you use this all the time, if you want, more talks on this specific tool. Yeah, we'd love to. This is really something we do all the time, and we find it extremely useful. So yeah, happy to talk about it as much as people need. All right, so now we're going to do that iterative thing. We're going back to the bin scatter. So this was our first bin scatter. We had our reagent dosage, and we had our float recovery. It looked like this. But now we have our integrated recovery that we've removed the feed grade relationship out of. And in this case, the difference is actually quite subtle. It's not a huge difference, but it is still there. And you can't, it's hard to tell on this graph because the axes are at levels of 5, or the notches are at levels of 5, but there is a slight difference. And what these secondary bin scatters, so once you go through integration and come back to bin scatter and go through integration and come back, what you might be starting to form in your head is an operational recommendation. So if this was me, I'd kind of be like, that's a big jump. I think we should do a test on if higher than 3 gram per ton and lower than 3 gram per ton as 2 groups, and would that actually have a statistical significance in means? So that brings us to testing, or in this case, a t-test. So I'm sure many of you are familiar with the t-test. Give me some thumbs ups if you've used them, maybe in Excel or in other programs. I'll just assume you have. I won't go into too much detail, is what I'm about to say. So if you're interested in the statistical work behind this, there's plenty of resources out there, but we also have a knowledge hub. There's a Clarofy knowledge hub. We call it Claramente. I think, Jacob, you'll be able to put the link in the chat. So please feel free to avail yourself of some statistical information as well. Okay, so t-tests, all we're trying to find out is when we've got 2 groups, are those two, is the difference between those 2 groups, or the difference between the means of those 2 groups, due to natural noise, or is it statistically significant that these 2 groups are different, or the means of them are different? So I guess one thing to remember at this stage when you're doing tests is that your outcome may be different to your original hypothesis. So you might have had a really good hunch and you've done your exploration and you've come into a test and the test gives you the opposite of what you expected. So you need to kind of, at this stage, you need to kind of keep an open mind to what the data is telling you, as opposed to what you want to see from the data or what you want to hear from the data. And that's, that's tricky. And most of the time, and I'm sure many of you are aware, most of the time, the result is you need more data. Like, we just don't have enough data to be sure of something. So be aware when you're doing t-tests, like everything you've done before kind of feeds in, and you want to be you want to do your analysis in a way that shows integrity to the data. Okay, so this is the same graph I was showing before. Our recommendation now is that group A, which is kind of below 3, and group B, which is above 3, will have a difference, because if that test comes that there is a statistically significant difference in means, that means we can now run a trial, a practical trial in the plant. So let me show you how to do one in Excel first. Okay, so again, a few steps. Just bear with me. So first thing is you want your 2 groups. Apologies for my laser pointer going all over the place. All right, so you want your 2 groups. So the way I separated out the groups is I used the filter option. You know how you can make your headers have a filter, and in the filter I selected one of the groups, and then I copy pasted that into a new tab, and then I select another group in the filter and I copy pasted that into adjacent columns. Right, so you copy those 2 things into a new tab. Don't forget to label the columns. And then what you're doing is you go to your Analytics Toolpack add-in. So I'm not sure if you guys are familiar with Analytics Toolpack. It's quite handy. It's included in Excel. I don't think you have to download it or anything. It should be just available in your add-ins. It's a tick box. But if you're having any issues with it, I think, Jacob, you might have a link, just like an Excel link or something to either download it or look up help on it. But anyway, within Analytics Toolpack, there are a bunch of tests you can do. Before you do a t-test, we actually need to know, because there's actually 3 t-tests you can do. You can do a paired t-test, a t-test for equal variances, and a t-test for unequal variances. So we need to find out the variance difference in our 2 groups. So to do that, we do an f-test. An f-test is another statistical test, and very simple. On Excel, you get this kind of input box. You put in your two columns here, and when you run it, you get a table kind of like this. All you're trying to find out is if f is greater than f critical, the populations are unequal. So we will use a t-test for unequal variances, and this is what happened with this data set that I'm using. So we're going to use the t-test for unequal variances. There is a lot of support on Excel about how you would use this statistically, but it is a bit of it can be a bit lengthy, the process. Another little tip: for some reason, Excel needs your the first variance, so variable 1's variance needs to be higher than variable 2's variance. So if otherwise f-test doesn't work. So if you do it and you find that your variance 1 is smaller than variance 2, you'll have to swap them over here. Just a little tip. Okay, so now you know if you have equal variances or unequal variances, then you do the appropriate t-test for that. Doing a t-test similar to this, you have a little input box, you put in your 2 groups. When you run it, you get a table like this. The only thing you're really looking at is your 2-tailed p-value. You want this, if the p-value is greater than 0.05, and 0.05, by the way, is your alpha here. So that means you're doing a 95% confidence interval. That's the most common one. So you can leave it there if you're not sure. So if it's greater than 0.05, there is not enough evidence to say there is a difference in the means. So there's not enough evidence to reject the null hypothesis, if you're familiar with that terminology. So the value I got for this data set was very small, so times 10 to the power of -6, so lots of zeros at the start, which is definitely less than 0.05, which means my difference in those means is significant. So in the context of the example, that meant that we could now go run a trial if we wanted to, or find out, okay, I know it's significant. I know that operating at this range is better than operating at this range. How much is it actually worth in recovery? And we would go into the evaluation stage. However, just before we do that, I'd like to just, I guess, reflect on what we have been doing so far in Excel and what I've kind of been going through in Excel. So you may have noticed that there were many steps for each of these tools or methodologies, and it's not quick, right? Excel is inefficient for conducting analysis, especially explorative analytics. Excel is kind of great at if you know exactly what you want and you just want to create a graph and make the graph the most beautiful graph in the world. Excel is good for that. However, the kind of analysis that we tend to do, that most people tend to do, is kind of explorative. You want to try something, then you want to try something else. You want to try the same thing on different variables. You want to be able to bin, be able to remove an overwhelming variable. All that is quite involved in Excel. And what we've developed, Clarofy, is basically overcoming some of these problems that we are seeing on Excel. And if everyone's okay, I will do a quick Clarofy demo to show you all these steps that we've just done in Excel and how easy they are to do in
Nishara,
Clarofy.
if I can interject a little bit,
Yes,
we haven't done this before, and we want to try it out with this cohort today. We want to actually try and just put a a multiple choice question. It's tailored around this discussion. This is what we believe and what we've discovered in discussion with a lot of customers and co-developers. But we'd like to get your feedback on it. And it's the question around whether Excel is sort of fit for purpose for data analytics in heavy industries. We'd like to put a poll very quickly, and then you guys can just vote and let us know your insights. That'd be really appreciative.
Yeah. Okay, so let me see if I can jump into Clarofy.
Okay, I've just sent the poll out to everyone.
So I have changed my screen. Just let me know if you can see a kind of a blue screen behind me.
So yeah, the poll might be in front of them. So
poll's in front. Okay, I'll give you a minute.
But it's still there. Yeah, just give a minute, and then we'll continue. Appreciate your feedback.
Back. Good to go?
Yeah, I think we're good to go. So appreciate it. If you guys can just put your answer in. Nishara, we'll just keep going, but I'd really love to know your thoughts on this.
Yep. So so this is Clarofy. We are excited to develop it. There's a lot coming ahead. So I'll just show you a couple of quick things that we can do. So easy to upload data. I've just uploaded the data same data that we were looking at in Excel. This is quite typical of plant data, but your data might be different, obviously. But Clarofy is able to upload many different types. Let's go to plots. So in Clarofy, you have this option where you can set your variables and look at your plot right here. And if you want to bin it, all you have to do is 2 clicks and it's binned. So you don't have to worry about your putting formulas for medians. If you wanted to change it to something else, you could. If you want to change your bin size, it's very easy. You just do that. And if you wanted to compare that with I think this is the same variable. If you wanted to compare that with the scatter, it's very easy to do. If you wanted to have multiple bin scatters, as I was saying before, normally we would, just add like 30 plots, put them all as bin scatters, maybe do a summary plot and have a look at it. So very easy to do and Clarofy. Next, we would want to integrate some of this, maybe by looking at the bin scatters. We realize that there is an overwhelming variable, in this case, feed grade. I'm going to use a regression line, very simple, but we do also have the spline option. I'm just going to run integration. Again, 1 click. This is what the graph used to look like, and this is what it looks like now in this new model. If I wanted to do multiples, again, very easy. All I have to do is tick the variables I want to use, and it's already done in a click. This new variable, now I can save it to my current data set. So I will do that, but I'll just undo these first. So I just want to remove feed grade for this example. So I'm going to save data set. It's now in my data sets over here. I'm going to make this new integrated recovery as my KPI, and then I go to my t-test. So I pick my variable, very easy to do. I know my groups were 3, were split on the 3 gram per ton level. So I'm going to do minimum to 3 and 3 to maximum as my 2 groups. Your groups, you can add as many filters as you want. So say you want your group where, from the start of March to the end of May, plus when we ran this level of pump speed, plus when we did this, like you have multiple things you want to filter by to group. That's very possible on Clarofy. So when I hit execute, what I get is three things. I get a visual representation of my two groups, so I can see visually, like that looks very definitely like there is a difference in means. I get a little description. So if I didn't know about p-values, or if I just wanted to know if this was a real thing or not, I could just read this. There is a statistically significant difference in means. That difference is that 2.79. If I then wanted a bit more information, that 2.79 is actually between 2.03 and 3.56. So I kind of have a little confidence interval there as well. And then on top of that, if I wanted a bit more information, if I wanted to check that my data point counts for the two groups were similar, that's often something we want to check, because you don't want to be making a decision on like 2 data points as opposed to 200 data points or something like that. So you want to check that your data points are similar at least. You got your standard deviations and your variance, and you got your p-value. So the reason that p-value is 0 is because it's too small. So it's actually, as we looked before, it's very small. So I think after a certain amount of decimal places, it just goes to 0. So we're happy with that. And as you can see, a couple of clicks, very easy to do. I'll just point out the only difference between this data set and the one on Excel is I had put some filters in previously. So I had made sure that some of our outliers were taken care of. So, and that's it. So you can see without much effort at all, I have basically done our binning, our integration, and our t-test really quickly and easily. And that's essentially why we designed Clarofy, to make these things kind of quick and impactful. So we want our metallurgists, our process engineers, to be able to make quick, impactful, data-driven decisions. Okay, so let's go to evaluate. So normally, if we have a result from a t-test, for example, that's usually not enough to say that's the amount of, in this case, recovery that we're going to improve on. So remember that 2.7 value or 2.6 value or whatever. It doesn't mean that, just if you think about it mathematically, according to the, how much data points you have, we're just saying for, in this case, like 168 data points, we already operated there, and that's a better place to operate, if you like. But it's not telling us what if at the other times, at the times when we were below 3 and the times when we were above 3.75, what if we operated at this one? What if we move these data points to that place of interest, if you like? So all you have to do for those two is two t-tests, and that's what I've done to get these values. So what we're after is the potential recovery change by moving the points from these two into the recommended operational group. And what we ended up finding for this data set is this is about 40% of the data points. So 40% of the time we're off. This is about 50% of the time. So we're actually saying 50% of the time we're already operating in this target position. For this overdosing position, we don't actually operate there much. It's about 10% of the time. So our data points, or the change that we get, in fact, this one's a negative one. So the change that we get doesn't make as much of an impact. So all I've done is a weighted average here. So these two values are weighted averages. I'll just point out these two, the low recovery and high recovery, I got from Clarofy, because we get the confidence interval, the low value and the high value. If you're doing this through Excel, you can just use the mean. So you won't have this last column, you'll just have the mean over here, and you do a weighted average. So for this example, the weighted average tells us that if we operate all the time in this, optimized operating state, we're going to get between 0.67% and 1.6% increase in recovery. So if you have worked in copper gold, that's a huge amount. That's like your maybe your yearly KPI, maybe for 2 years or something, that you're trying to achieve over a whole year with all your improvement projects. So this was a good result. However, it needed to be tested. So that's what in the actual situation, that's what we did next. So as I said, the difference between groups doesn't equal potential uplift. So that was a calculation that we just did over here. And our conclusion was changing our reagent operating window should result in this recovery improvement. I guess another thing to just be aware of is similar to getting something that you weren't expecting out of your t-test or your testing stage. We want to be realistic about our ability to control the plant to meet our recommendations. When you have the data, when you're looking at the data, it's quite, you can manipulate it any way you want. You can say, what if we did this? What if we do? You can ask all the what if questions, but all of those scenarios aren't practical, right? Like you won't be able to do everything. So we need to be realistic about that. So, for example, it might be really clear that if you turn up all the pumps to 100%, you might get some good recovery, or you might get some good yield or something like that. But, the pumps will all die and you'll get spills, and, it's just not practical to do that, right? But you want some like optimal level of that. So another thing that we often say here is there's no value from this data, or there's no value from this result that we've got if there is no action at the end, right? So you don't really know if something will work until you try it in the plant. So when you have a tactic like this, which is just change recovery addition, it's something that doesn't cost much to implement. In fact, it probably costs nothing to implement. So you want to ideally be targeting your analytics for things that are low cost and getting results like this in order to improve your overall plant performance. All right, so that's all for the main framework area. Again, you saw how easy Clarofy was to use. We believe it's the right tool for this sort of jobs. Obviously, you're saving time. Probably my main point of a benefit is it's an objective decision framework. So it's definitely more than gut feel, but you can check your gut feel, right? So if especially if you've worked in a plant for a period of time, you understand certain things about the plant, and what's like, usually by looking, you can tell what's wrong or things like that. However, with Clarofy, you can have the data to back up your hunch. As I said, this particular customer, we did an implementation. We did a trial, and the actual uplift was so much more than we recommended. It was actually 2.6% increase in gold recovery, which ended up equating to $17 million per annum of additional revenue. So very happy customer there. And you can see from the steps that we took that it wasn't, I guess it wasn't onerous to do that stuff. It just needed a methodology, and we had to go back and forth to make sure that we got everything right. A few little things about Clarofy. You would have seen very easy to upload data. We now have capability for cloud connection as well to your data source, your data lake, your historian even. As I showed, plenty of plotting options, integration at the click of a button, definitely one of my favorite features. And of course, the t-test functionality. So you're getting your results in multiple ways in there. So thanks for sticking around, everyone. We'll have some questions in a minute, but I'll just point out that usually our next step, if you're interested in any of this, or you want to know more, or you want to have a go at Clarofy, please book a demo session with us. We can go through more of our own kind of anonymized data, or give us some of your data that you're working on, and we will try and find some good insights for you straight up from Clarofy. We definitely believe in our quick and easy methodology, so we'd love to show you some of that. Anything to add, Johnny, before we go to questions?
No, I think you covered it pretty well. Probably just to summarize very quickly, the importance of having the right tool that's fit for purpose for the job that needs to be done. And in the age that we live in today, it's all about making sure that you're on that digital transformation journey. What steps are you taking towards it? We're all about making sure that we start doing those transformational steps at the basic, a bottom down approach, helping the people to achieve more with the data that they have, right? Data has just grown in utility, and we believe that's where the value add is. So Clarofy is all about helping everyone at the end access to the data to make sure that they can drive real transformational change over time. So that's basically, I think we hope that came out clear in the session. And we hope that we can join you guys. You guys can join us in another session, or just book a demo with us. Or if you want to just talk to us about the space, your pain points, we're more than happy to sort of sit down and talk to you about it. We're passionate about the space. We love what we do, and hence why we've put it together in a product and taken it to market in the most affordable way that we can. That can really reach and make an impact. So yeah, thanks for that. And I guess we'll open it up for some Q&A. Check if you can open some of the mics if anyone's got any questions.
Let everybody speak. You can also put them in the chat if you don't want to speak.
Yeah, or if you don't, you can just put a question in the chat, and if you can answer the poll as well, that'd be great, because I'll close it off in another minute.
I think there is a Q&A section as well. We can look up all the.
Pedro's got a question.
Yeah.
Hi. Thank you for the presentation. That was very clear. I was just wondering, what happens if you have, because you control for feed, but what about other variables that have impact on recovery?
Yeah, for sure. I mean, you, like, statistically, or in terms of the data, you can do that for any variable, but generally the only thing you just got to keep your contextual knowledge. So many of us here in our team kind of have done data analytics or data science as a secondary thing, but we all used to work on site or have some kind of site experience. So we have a bit of context for the data that we have. So that's probably what's a little tricky with integration with the controlling for variables, because you can do it with anything. You can just take all the all the effects off, but it's finding the right things that need to be taken off in order to see the relationship of interest, right? So in our case, we were looking at reagent, and it was too small a change it was too small, and the feed grade relationship was kind of overwhelming it. Like, we couldn't tell, is this happening because of reagent change, or was it just a feed grade change? So, but yes, you can definitely do multiple integrations, as I showed in Clarofy.
Pedro, are you kind of asking if Clarofy can handle that sort of like a control for multiple variables, like a multilinear regression plot?
Yeah, I suppose. Well, not necessarily Clarofy, but like with the example that you gave.
In Excel.
Well, like the one in Australia for the gold.
Oh, yeah.
In a real scenario, right? Because you might have to
sure.
account for residence time and airflow.
Okay.
And like that.
Definitely. So residence time, you can slightly different thing. You would do maybe a lag in your variables, so that it's everything moves down a little step. Like, it depends on how frequent your data capture is. But yeah, everything else as well. So if you're doing it in Excel, You just have to do the whole. So you do it once with the one variable, for example, feed grade, and then you do the whole thing again with whatever other variable you want to remove, and you just add to that equation that I said, predicted KPI plus the mean of the predictions. You just add the second one in there as well, so you end up anyway. It's possible. Is what I'm saying. Yeah.
Great. We got thanks for that, Pedro. Hopefully we've answered that. Mike.
Yeah, thank you. Can you hear me? Sorry.
Yeah.
Yes, you're loud and clear.
Okay.
Mike.
Perfect. Two questions actually, or maybe one comment, one question. The comment would be, I mean, you've shown us an example of a plant, right? Like a processing plant, but obviously the tool can be tailored to be used on anything, right?
Yeah.
Exactly.
That's the one thing. And the other one is, are there limitations on row counts at all on the tool?
You're saying in terms of the size of the files that we can import into it?
Yeah, the size of the point, the data points, practically and technically, I guess.
I think we're only limited at the moment by the CSV sort of format dump. So I guess Excel. We mean we can. I think we've imported in files up to the size of about a gig or more. And then it just gets a little bit laggy. But again, it's just something that maybe we just scale out them. So Clarofy is sitting on the cloud, so we can scale out the machine for a particular customer. We can scale it out and put it on a high-end computing machine. Just got more grunt, more power. It's the beauty of the cloud, right? So, but yeah, we really haven't had any real limitations other than that. But most of the times, sort of Mike, where this sort of leads is everyone kind of starts off with a couple of CSV files, and then the question very quickly moves to, can I get it to my Pi historian or whatever historian flavor you guys are using, whether it's Aspen Tech or whatever.
Exactly.
Yeah, that's the next step, and then we just feed it near real-time data.
Yeah. Okay. Thanks.
With data, like rows as well, I mean, when you're doing analytics, it's just an important thing to think about, like, is it useful? Like maybe you get your data minutely or, every 30 seconds or something like that, like something quite granular. And you have to think about, is it useful to be analyzing at this frequency? So I mean, it's a side point to the actual, will it work with 100,000 rows? But sometimes maybe you don't want the 100,000 rows, so it's just something to think about as well in terms of what analytics you're doing.
Yeah, the quality of the data is important. That's where and cleaning and prepping becomes a big part of the work, which is something that we're going to be touching on in the near future as well. We've got some data prepping and cleaning functionality that we're
next webinar coming up will be
showcasing. Yeah, the next webinar we're going to try and talk a little bit about some tips and tricks around it, and then how we've catered for it in Clarofy.
Oh, thanks everyone for sticking around. Any other questions? Have we got any in the chat? Okay, great.
Awesome. Okay, well, thanks everyone for jumping on. Thanks to Nishara for presenting, and really insightful session. So please, everyone, be aware. We'll probably send you guys a couple of communication pieces with other recording, and just keep an eye out for the next sort of webinar series. Any information or input you'd want to pass through to us, we'd be more than happy to have a chat. Again, just there's a couple of links there to book some meetings with us in the chat. If not, you'll see it in the presentation at the end. So please reach out to us. We're more than happy to sit down, have a coffee, and talk analytics and pain points in your industry. So yeah, thanks for making the time. We know that it is late for you guys, so we really appreciate you making the time being here with us. And on behalf of the Clarofy team, thank you very much, and we hope to see you in the next one.
Thanks all. Bye.